Hello everyone, I hope the power rule video helped a little. I'm back now to take a look at the product rule. As you can see here, and we're on page 4 in your notes for lesson 4.5. As you can see here, the product rule is essentially a function that's made up of two other functions multiplied together. Now that could be two brackets multiplied by each other, where each bracket contains a variable. It could be just a variable in front of a bracket. So any combination of two functions multiplied, we have to use the product rule. Now, how does the product rule work? Well, the derivative of the whole function is basically broken up into four parts. So you've got the derivative of f of x, so the first part, times g of x, and that's what we have here. Then you've got always plus for the product rule. Really, the derivative of g of x times f of x. Right, so if we've got two pieces, so let's say this is 1 and this is 2. So this is the derivative of the first times the second plus the first times the derivative of the second. Right, so break it up into four parts, and we apply this order of operations to it. So I'll look at a couple examples in a minute. The proof is a little more complicated than the power rule proof or any of the other proofs. However, it does come down to grouping again. So you plug in your values, your f of x plus h and your g of x plus h minus f of x, g of x, and you group. So what we want to do is to be able to factor out the terms that don't make the limit definition. So this is all about organization, and when it comes to this problem, this is really the key part here. We're putting in 0. F of x plus h times g of x negative plus f of x plus h times g of x positive. So that means that essentially equals 0. So we have to manipulate the proof in order to be able to create the limit definition of g of x and f of x. So that's the hard part with this proof, and that happens in some proofs when you need a component that's not already there. So you can take a look through the rest of it. As you can see right here, this gives us the derivative of g of x, and this gives us the derivative of f of x. Because it's addition, it doesn't really matter which one goes first, as long as you pair them up as the derivative of one times the other plus the derivative of the other times the first one. So the order is not a big deal as long as you have them paired up properly. Now, what does that look like in a question? So I'm going to jump over to page 8. Back to the question I did yesterday. So this is page 8. Now the question I did yesterday, I said you could use the power rule or the product rule, and it's your choice. This one, really, the difficulty is kind of about the same. However, if we go back to the rule, so we've got two pieces. If this is f of x and this is g of x, then this would be k of x based on our notation. So what I want to do, I'm going to use Leibniz notation for this one just to show you how that would look. So if we're getting the derivative with respect to x of y, then that's going to equal, so it's going to be a little bit long-winded here, but I want to show this, the derivative with respect to x of the first bracket, okay, and then we're multiplying that by the second bracket. So be careful with the notation. So this is the derivative of the first bracket times the second bracket, plus, now I always like to put the derivatives first, so the derivative of the second bracket times the first. And that's one way Leibniz notation would look. Now we work this out. So dy dx, we can turn it into one fraction in the notation because there's nothing else to do there. The derivative of x minus 2 is just 1, and then our bracket for the second term, plus the derivative of 2x plus 3 is just 2. You get x minus 2. Now we've got the algebra to deal with, which gives us 2x plus 3 plus 2x minus 4. We simplify into 4x minus 1. And that's what we had yesterday using the power rule. Now with simple derivatives like x minus 2 and 2x plus 3, most of you guys will probably get to this step very quickly. Like that first step, you don't really need to show that, but I wanted to just give you an idea of what Leibniz would look like, or Leibniz notation would look like. I'm just going to do one more because it's a popular multiple choice. So if we jump over to the next page, page 9. This type of question gives you the derivatives and the non-derivative values. So we're doing product rule because it's f times g. So we want the derivative of f times g at 2. And we're given all the values at 2. So f at 2, f prime at 2, g at 2, g prime at 2. So this is a multiple choice because there's very little calculation. It's more about organization. What you need to understand is the rule. F times g, derivative at 2, would be the derivative of f at 2 times g at 2, right? Derivative of the first term times the second, plus the derivative of the second term times the first. And we have all those answers, so that's why it's not a difficult problem when it comes to the calculating. It's about the organizing. So we just go up and pick the right one. We get 6 times 7 plus -1 times 5. We work that out. We have 42 minus 5, and that will give me 37. Okay, so that's a couple of product rule questions. They get a little more complicated depending on whatever your two terms are. But for the most part, you'll see a bracket times a bracket, and then you do derivative of each bracket and organize it accordingly. So I'll leave it there. I'm going to do another video in a little bit on the quotient rule. So stay tuned, and I'll be back with another video shortly.